Welcome back to Meet the Makers. Today I have another great guest on the 3D printing side with us. He builds drones, works on Arduino projects, and blends his knowledge of geology with 3D printing for some of the coolest maps you've ever seen. Super excited to have Matt from MattsWildScience here with us today. Thanks so much for jumping out with us.
Thanks for having me.
Yes, of course. Can you just tell us a little bit about how you got into 3D printing and making things in general?
Sure. It was probably back during COVID lockdown when we were all stuck inside. I got into a couple things. We got into three-dimensional visualization. That's a really important part of teaching students to be geologists. And so you might think, oh, we teach them different types of rocks and minerals and stuff. But truly what we teach them is how to think in multiple dimensions, not only on the surface of the earth, but down into the earth and through time. And so multi-dimensional thinking. And so we started experimenting with things like VR, AR headsets and smartphone interactive technology because we weren't in person anymore, right? We couldn't go out and look at rocks, and we couldn't take the kids out and have them with maps and learning. And so we started experimenting with all these weird things. I was just bored at home and bought an Ender 3 and started printing my first droid, which was more for fun, but I had started looking into it at work. And I started with an full-size R2D2 was my first project, all with just an old Ender 3. And then that has spiraled because an Ender 3 doesn't churn out prints very fast, and I'm not very patient. So then there was another Ender, and then it spiraled. That's how I got into it. Now a lot of printers around. The combination of work and boredom at home during COVID.
Yeah, I think a lot of us seemed to during COVID get into things around that time. It was slightly after that I got into it, but R2 is a pretty insane thing to take on for one of your first projects. I started with something about this big. When you started that had to be a pretty large undertaking. Was that something you just dove right into that?
Yeah, I shouldn't have done that. That was bad. All the files for there's a very official kind of set of files that are floating around out there freely available for the R2 stuff. It's cut to fit on an Ender size or kind of small format printer. And I just got religious with it never wasn't running. It was always running. And then there's a bit of fun when you're new to it and you get things to start sticking to the build plate and you get really excited. So each day was almost a new part. By the time you get the dome built, then there's hours and hours of post-processing to get the dome glued together and smooth. And while that's happening, you're printing the next batch of stuff. At that point, I bought a second one. Actually, at some point, I realized I couldn't print the feet without even a bigger printer. So I got a CR10. It just spirals out of control. And I think that's what a lot of us have gotten into. We need one more thing now.
Absolutely. I wasn't printing anything nearly as ambitious as you, but even for me, at my first, I had an Ender 3 V2 that I started with. And right away, I was like, man, this is way too slow. There's too many things out there I want to print. And I had to grab another one. And then eventually that leads to this printer and that printer. No, totally relatable there. Do you even know how long did it take you to print that from start to finish?
I started in, I think, November. And so I probably had the full body done maybe in March or April. It was definitely before the summer because I couldn't paint anything because it was too cold outside.
Oh, okay.
I remember having all this stuff ready to paint by spring, but that's like full nonstop running. It almost never was down. I would even mess with the speed a little bit.
Yeah.
If I knew, speed it up a little bit. That way I can get it done by 10, change it out, get a new print going overnight. Messing with settings to never let it be down to get those big projects constantly. Almost call it campaign printing. Just never stop.
Obviously, I knew that you had done the R2 project, but I had no idea it was so early in you 3D printing that was something that you did. I know a lot of people who they've been printing for years, and it's like a project that they dream of doing, but it's a big undertaking.
Yeah, I should have gone the other way.
Yeah.
It's not really mobile anymore because it's not as high quality as I can do now. And so things are creaking and breaking. You're seeing some of the, I guess, not just wear and tear of age, but my lack of experience when I made it. I could do way better now with all the different stuff I have.
Hindsight's always 2020 when you're looking back at those older projects. For you, where you're at now with your skill level and the different things that you've learned from 3D printing, for somebody, whether it's their first project or they've been printing for a while, anything that you've learned from doing that project that you would steer people away from doing or would have done differently this time?
I think up until recently, I've always liked the start with a cheap printer and learn how to do that approach. I think I'm changing my mind on that. I think because I've got a pair of bamboos right over here and they're just great. That early frustration of having adhesion problems or filament snags or any of these little things that can get really frustrating, they don't ever really happen on these things. I think if someone started on one of those, the likelihood they would get burned out and irritated is much lower. That being said, I can fix anything on these because I've had to fix it on an ender. You always have to get in there and fix stuff on an ender like all the time. I'm not really sure the best way to go with whether expensive or cheap. I've always kind of, I don't know, changed my mind on that. But file organization, that's important because, I mean, R2 had hundreds of parts to print, and you don't want to print duplicates because then you're tying up your printer. So having a good system of methodically moving through YouTube is very useful. Everything you could ever want to learn is somewhere on YouTube if you can find the right file or the right video. But yeah, I would probably have started smaller for sure. Also, this is crucial, a trash management or waste management plan, because you're going to have so much waste and supports and stuff, and it's really easy to get everything junked up and lose stuff. Those are things that I would have thought about more that would have saved me a lot of effort early on, because, you know, what are you going to do with all your supports and how are you going to deal with all the trash you accumulate? There's a lot of trash that you make from doing this. Boxes, spools, whatever. And if you don't have a huge printing space, that could probably overflow more than the printers. It's storage for filament. Where are you going to put all that? So those are all kind of things that if you're going to get into, I would preemptively think about, because otherwise this can just expand to a huge operation, and even just one printer. Yeah. So those were all organizational things, weren't they?
They were, but it's all good advice. Even just to your point about the trash, the biggest thing I've ever printed myself was a Mandalorian helmet, actually. And just off of that project, the amount of supports and scraps that I was pulling off, like cans were like overflowing constantly. Yeah, I'd have to imagine with something like an R2, or I know you've done other droids or just various things, it has to get out of hand quickly over there.
Calibration runs that it does at the beginning, because you're trying to get rid of them. 1,000 different ways to make trash for this. The little flyers that come with every filament roll, I don't need instructions anymore. You know,
the little silica gel packets that I have all over my house.
The humidity has to be super low in here because of all the desiccant packets floating around.
Absolutely.
Literally one right there staring at me.
You can't escape them. One of the things that you mentioned throughout that, I haven't worked on a project of your size, but even when I've worked on bigger projects, it does get out of hand quickly when you have all these parts. And it sounded like when you worked on your R2, it was the winter time maybe for part of it. You didn't have stuff painted yet, so maybe it wasn't all assembled together. What was your system for keeping track of the different parts and all of that?
Yeah, those little plastic organizers you can get at Walmart. Bins right here.
Oh, yeah.
They'll all have a stack of those. And then when I'm pulling parts off the printer, because it may not all be in the right order. So if I'm printing something that has 3 stacks in there, I could be printing legs going into one container, the dome in another, or even different projects. That way I can just yank them off the build plate, throw them in there, and it's organized. I've got several of those little containers. I've got some really cool IKEA ones I found that I think are for laundry. But they stack really nice, and you can put really big parts in because you pick the little laundry situation up, and you can just throw big parts in there. And then they're organized, and you don't have to go back and figure out what it is and can label it. More organization stuff. But yeah, that's how I've tried to keep everything in one spot, because, you know, it easily will explode everywhere if you don't. But that's worked really well, and that's super cheap, $15 maybe. I think the IKEA things were like $20. I like those. I wish I could find more of those.
I haven't thought of organizing things that way, but anytime I have a project that expands over multiple days or weeks, it's easy to put a part down, misplace it, then you can't remember if you printed it or didn't print it. That seems very helpful.
And then you reprint it.
Yeah, then you find it.
You're going to find the other one.
Exactly. Yeah. Now, for you, at the start of getting this 3D printer, like there's so many, in my mind, so many hurdles to overcome when you're building a project of that scale. It's not just learning how to 3D print and getting that piece together, but you've also got the post-processing piece. You've also got the piece of the electronics. Out of all the stuff that you had to do for this project, was there any one piece that I guess you were the most intimidated by, or any one piece that gave you the most struggle?
Painting is the hardest, I think. If you try to make it meticulous, sometimes you'll hear folks talk about the 5-foot rule. Can you notice an error from 5 feet or 10 feet, or how good do you want it to look? But you're always like 2 feet from it. I have trouble passing the 1-foot rule, because if I can see it, I know I'm gonna see it. And if you don't get it quite right, then you might just be sanding and starting over. It's not smooth enough. You didn't tape it off well enough. That's super frustrating, because then you're gonna have to resand it, maybe reprime it, retape it, and paint it again. It's just an endless loop of painting. And I think that took the longest time to give up wanting it to be perfect from 18 inches away.
Yeah.
Because at 10 feet away, nobody is going to know those things are there. I've seen other people talk about this before too, where I see 30 errors, and then Other people come up and can't see any of them. It just doesn't register to them because they haven't been in there with a piece of sandpaper trying to fix these little spots. That was the hardest, being able to accept something is not perfect, especially when it comes to that painting part or ripping supports off. You rip some supports, something doesn't look quite right. How much is it worth of my time to fix that? I think that was the hardest time, is gauging how much time do I need to spend here? When do I need to move on? The electronic stuff, I've always found that's fun. I don't get as frustrated with that as much. And that one didn't. And that one there's so many tutorials on how to use Arduinos and Raspberry Pis. You're almost never too lost on that. You can find it. It's super fun. And then when you get to work, it's this great victory. The lights are working and you're sitting there staring at this tiny little screen. That's your celebration. But yeah, it's always been that post-processing that's been tricky to figure out what works best and is the quickest and most efficient and looks the best. Spent a lot of time working on those kind of things. A couple years ago, people were using the Bondo to do a lot of the layer line blending, and entirely from that to the paste. You've ever seen the acrylic paste?
Yeah. Are you, the Liquitex, is that what you're using, or a different kind?
Yeah, using the acrylic paste here.
Yeah. Oh, yeah.
I've been using the UV resin as well, because you fill it in, blast it with the light, and you can sand in 20 minutes. And you can't do that with any of these other techniques. That cuts a lot of time out. But that's been the learning curve, is what works best, what's the speed. You got to get all the PPE to work with the UV resins and lights.
Yeah, it's such a give and a take of what level of PPE do you want to get out for the day, or how many supplies do you want to get out, or how many hours do you want to wait for your stuff to dry.
My breath. I'm going to sand. It's always a game.
For sure. Yeah, something interesting, I think you said in there, and I guess I would have known if I really thought about it, but it clicked for the first time for me, which is working on things like Arduinos or electronics. It's so binary. Either the light's going to light up or it's not. It's going to work or it's not. Post-processing, it really is that. It's like done's better than perfect, but it's so easy to be like, man, it's just not quite right. I think that's so hard sometimes to move on from those projects when it's just not quite to the standard you want. Something I always think is, I can see a video of my stuff that I post online, and it looks so good in the video because it's far away. Maybe people get hung up on that, of seeing other people's stuff online. If you're not seeing it in person, you don't really see those imperfections the same way you do on the internet.
Kind of like the Instagram effect. People see all the beautiful Instagram pictures of the national parks, and then they go there and it looks cooler on Instagram. Filters and stuff. With Arduinos or with programming and coding, sometimes the error's there as long as it's doing something. Sometimes the errors are really cool because you hadn't anticipated doing something weird if you're trying to get a screen or a light sequence or something. So sometimes those errors turn out really positive because it's maybe something that didn't occur to you, and then you have erroneously written the code to something you like better. I've had that happen on especially little screen displays. You want to do something very specific and you mess it up, and then it does something else, and it's nice. Bad news is it's hard to replicate it because you don't really know what you did.
For those Arduinos, for people who maybe don't have a background in working on projects like that, or they're just getting into it, anything you would recommend for beginners on that side or first projects?
You can buy a kit that has all these things in it, all kinds of sensors and lights, LEDs. You can download everything off the website and at least learn the basics, because there are all these examples in the Arduino stuff that you can not only look at and figure out, but you can just steal that code and adapt it to whatever you need. And so that's probably the best way. The other way is, I've had a lot of problems with knockoff boards. Arduino is obviously the one name brand, but the Elegoo company that makes a lot of those printers, they also make boards, and those are pretty good. But then I tried to get cheap and buy these cheap boards and spent tons of time trying to get them to work. They just don't work as well as some name brand boards. But if you're using the name brand board and you're following these tutorials, you can do just about anything. The Arduino website, so like it's arduino.cc, they have so many, I wouldn't even call them tutorials. They're like full project guides. There'll be multiple tutorials. They'll tell you exactly what you need and walk through. And then there's usually like a forum associated with it that people will troubleshoot. It's really informative. And so that's a good place to start. Start with lights and try to control lights. You can get sensors, and there's all kinds of sensors. There's LiDAR, laser sensors. I really like these ones that are called sonic. They're sonic distance sensors. They're really cool. And so you face the little sonic sensor at the wall, and it shoots. It can detect the distance based on the sonic response. Super cool. Like $1.
That's wild.
People built all kinds of crazy things, like little robots that can navigate in the dark because they're not navigating based on visual anything. They're navigating based on those little sonic sensors to just go around the room. It's really fun. But there's all kinds of weird little tutorials that you can use to figure that coding component out and slowly ramp up your complexity. When you throw some lights into a 3D project, it's kind of fun. You can control them to look like you think they should, like the R2 lights. They flicker like they should in my head, not how it really looks on the screen. I don't care about that. I want them to flicker like I want them to look. And so I can control that because I control the speed and what light comes on at what time, how many different sequences it goes before it cycles back. There's all kinds of really weird stuff you can do with Arduinos. It's really fun.
I agree. Adding, whether it's as simple as LEDs or whether it's more of the complex stuff that you do, I think adding those elements to the 3D prints, it just takes it from a whole new level of just, I hate saying just being a piece of plastic, but it really, it elevates it so quickly for the projects I've done. They end up being some of my favorite projects. I know a lot of people get intimidated by that stuff, but if I can figure it out, anybody can.
Yeah, that's what I think. If you spend enough time, you can figure it out with YouTube. And if you refuse to quit and get almost determined via anger, you win.
Yeah, absolutely. For me, I was pretty intimidated when I first got into 3D printing, and the 3D printing community was like, any problem I encountered, there was somebody there who they encountered it before, they knew the answer, and there was a forum for it. I think that's like a pretty similar thing with the Arduino stuff. There's great forums, and the comment sections are great, and there's always help there.
We have a big Discord group for the droid builders. There's so many channels. There's one just for electronics, one for 3D printing, and individual droids have their own channel. Everybody goes to those to post information and show off whatever they've been doing too. Because again, that 2 a.m. win with the electronics, you got to show somebody that'll really appreciate it. So you pop that up there and get a bunch of folks giving you thumbs up later.
Sometimes you need that moral support from somebody else at 2 a.m. when who knows what it takes to get that done.
Yeah, there's a lot of those droid builders up at 2 a.m. I don't know why. That's usually when they're doing stuff. So you get a lot of hearts and thumbs up at 2 a.m. if you post stuff.
For you, now, obviously you started your R2 back when you first got into this. Do you have any plans to do another R2 in the future, maybe a more complex one? Or what are other projects you're hoping for going forward?
There's another one right there that's in construction. This guy's built to be more resilient so that I can put my motors and things back in him. This one's all welded together. It's all plastic welded and much stronger. With the first R2, I was trying to get speed. So I was cutting down on things like infill and the walls, and I just as fast as I could. Even some of the supports. This guy is printed. I took my time and printed it much slower, and it is a hoss. But I've got all the motors and all the movable parts from the old R2 that will go into the new one that is more adapted to moving around. Last time he moved, it was just very creaky. It's not a bad noise. So it's going to go into that guy. He is all welded. Even on the outside, I've got some welds that look rough, and I like it. Looks like what it should, right? Yeah. But he is melted together and much stronger. But that's my next guy. His legs are all done. He needs paint and electronics at this point. He's come in for the winter because he can't live out in the garage forever. The legs got to get malleted together and welded because some people don't even use plastic for the legs. They'll use the wooden legs to have that additional support. Yeah. But I've started welding these other PETG legs. I'm convinced myself that'll be stronger and creak less than the other guy.
How much do one of those weigh?
I don't know. I gotta pick it out. It's probably 100 pounds or so with electronics.
Damn,
maybe a little less. I'll weigh it. I've never done that before. I'm curious now. Maybe 75, 100 pounds. It's pretty heavy.
Okay, I was not expecting it. I expect it to be heavy, but not that heavy. So it's interesting to hear.
That's with electronics and stuff in there. The batteries are a couple pounds alone, and there's two batteries. There's two big 12-volt batteries in there. The motors are the scooter motors, full round scooter motors. Those are a couple pounds. Okay. You can't move it very far with wheels. So yeah, you can roll it pretty easily, but it's pretty heavy. Yeah,
now that you say it, as I'm starting to add this stuff up, I guess that would make sense. It would be that heavy. I've heard some of the other people who do the dome, they do it in like ABS and they vapor smooth it. Did you experiment with any stuff like that, or did you do PLA?
That guy's all PLA. Okay. The body on there is the PLA Plus. I've moved up to it. And then the legs are the PETG. I've not done any vapor smoothing on these things because I've just been doing the UV resin. Right. And I mean, I know the bamboos seem to print ABS pretty easily. I just haven't. I've just creature of habit.
Yeah.
That I've got some ABS. I don't think I've had any problems with warping or anything on the bamboos with the ABS. It's hotter, it's more abrasive. I have to stick to what I know, which is the PETG and the PLA. So I stuck to them. Have you done a lot of ABS stuff?
I've actually never run it before. I just got my very first printer that has an enclosure on it. I've never had the opportunity to run it before, but I've been thinking about it. I don't really have anything that I print that there's a need for me to print an ABS. I've never done it, and I don't know that I
Same.
will.
I couldn't really, if it's it needs the thermal protection is the big deal if you're going to be heating up or something, but none of the stuff is. So I don't really see the reason. The PLA Plus seems to be pretty strong relative to the other things.
Yeah.
And it's not going to truly really be in the sun because it's painted with so much paint that it's not getting blasted with UV and it's not sitting in a car for a long period. So I don't have a lot of problems with the thermal properties of the PLA because it's just the frame, it's the body.
One of the things that I saw repeatedly in your content that made me laugh, and I've never seen somebody do this before on the painting side of things, is you use toothpaste a lot for battle damage. How did you come across that idea? You're truly the first person I've seen do this, but I love the results.
Somebody told me about that little trick. And there's another one that I've heard. You get salt water, splash it on, and then you paint. The salt water comes right off.
Yeah.
And gives you a different kind of scatter pattern of the damage than the toothpaste. And so what I'm thinking about doing is getting the two different types together.
Yeah.
So do a little bit of toothpaste and a little bit of salt water, let it dry perfectly, and then just wipe it clean off. It's super satisfying to wipe the toothpaste off.
I can see that.
Oh, yeah. And you can see it well. Oh, I guess the Boba Fett helmet. This dent was so much fun to get off because it was full of toothpaste. But it's got to have the dent, right? That's the key Boba Fett component. It's very rewarding to get the toothpaste off. The other thing I saw was they used two different colors of the same shade. So two different greens or two different reds. And you spray with one and then you move the toothpaste around a little bit and then spray with the other. You get this two-tone weathering. That looks super good too. The salt water, once you wipe it, it disappears. But that toothpaste, you just smush it a little. And then when you wipe it off, you can get these more complicated weathering patterns. It's super fun. Yeah. I'm not done doing that.
I've never seen somebody do it before. When I was watching your content, it's like, that's on my to-do list the next time I want to battle damage someone.
I stole that from somebody else. I don't know where.
Either way, it's a cool technique. For a lot of your stuff, I feel like you almost oversimplify. You don't seem to feel like it's like very hard how you describe doing it. You seem to make it seem easy. Are you just good at doing art, or how have you gotten so comfortable doing stuff like this?
It's done a lot of it. There's a lot of fails out there where I've tried different things and didn't like them and gone back. Yeah, it's trial and error, figuring out what not to do.
Yeah.
And can you learn to love it? Can you salvage it? Is there a way to salvage something that you don't necessarily like? Can you get some sandpaper out and salvage a small component? That Boba Fett helmet had a spot I didn't like, and I was able to salvage it without repainting the whole thing with some tape. There's a lot of knowing when to stop and almost not caring to mess it up more. Yeah. Once you learn to accept those errors, it doesn't bother you as much and you move on. Yeah. Like the helmet, there's a couple things on it. It's almost you were walking on like a beam on the ground. You wouldn't be nervous, but if the beam was in the air, you'd be nervous and fall off.
Yeah.
So if you stop caring as much, you seem to make fewer mistakes. I don't know how to explain that, but it just seems like when you accept it and deal with the immediate problem, you don't make as many goofy mistakes as you would if you're on the beam 50 feet in the air.
No, that beam analogy is actually a good analogy. I think it's almost like the less nervous you are, the easier it just comes together.
Worrying is not going to help you. Accept what it is, find a solution, and move on. Because I guess when I first started, I'd mess up something with the paint and I'd freak out and I'd try to solve it. I'd just make it way worse. I probably shouldn't have done anything at all. It's not the end of the world. You can always fix almost anything. So, especially if you're talking about the paint or the post-processing, you can almost always fix it somehow. Yeah. So you don't freak out as much and you don't make it worse.
I don't know if it's something that you still have. It's quite the sizable project, but at some point you had a Millennium Falcon control panel in your garage. Is that still in existence, or what's the status of that?
It has been disassembled and is moving from my garage is detached. It's back in the yard. And that's great, but I can't pull my car in there in the winter.
Okay.
So it's being disassembled and moved through that door right there. I'm in the basement, and so it's moving into the other part of the basement.
Okay.
If I walk out of here, the pan will be over there. It's going to be reconfigured a little bit, but yeah, no, that still exists, still works, and it's super fun because it's connected to Alexa, which is my favorite part. You just yell at Alexa, and then Alexa turns on the Falcon.
Cool.
Start flashing and beeping, and then I've got an Arduino program to randomly start firing off alarms. You have to hit the alarm button that's flashing at the speed of the beeping. Oh, my kid loves it. And but super fun. And there's switches, all kinds of, it's just like a giant fidget toy. You have to respond to all the alarms. There's one button that, I don't remember if I videoed some of this. One button will cue random Chewbacca sounds. So you can pretend to talk to Chewbacca and then he'll right back at you. But I want to move it down here. So I'm finishing that part of the basement to have my little spaceship through
Yeah.
it.
Yeah. No,
Yeah.
That's honestly one of the cooler projects that I've seen in quite a while. Like you've got a very dedicated space to have all these massive projects. Do you ever have a repair guy come over? Somebody has to come over to the house, and do people ever stop and just check this stuff out if they're interested?
The Orkin man loves coming over here. I guess his son is really into Star Wars, and so every time he comes over, he's sitting here just taking pictures of stuff. He's like, I didn't see that. Is that new? No, that's been there. Oh, okay. I didn't see that. But yeah, the Orkin man really enjoys wandering around the basement. And the garage used to have all of this stuff in here. It used to be out there, and I've moved it in because it gets cold here. I used to have to do the SD card shuffle, running SD cards back and forth. So I moved everything in here, so I don't have to do that anymore. The big printers are still out in the shop, but I've reduced the amount of stuff that's out there, brought it all in here. But yeah, the Falcon, that's a winter project. We'll see how much gets done. I've been moving sheetrock in there to get the walls built and turn that into a tiny little spaceship.
That's cool. Like I said, you have some of the largest and some of the coolest projects that I've seen in a while. Maybe if you continue doing this, I think you're going to need a bigger space or something, because I don't know where you're going to go from here.
I don't know what I would do if I've got a Millennium Falcon cockpit through there.
What else could you want at that point?
At some point, you just stop running out of things. There's only so many R2s that one needs. I don't know what I would do after that.
We were talking to me a little bit before this. You said you're working on a Stormtrooper. That's your current project right now. You have a Stormtrooper.
Yeah, I can't believe I don't already have one of those. I got the file a week ago and I've just been having these things nonstop running, which with the bamboo printers, super easy. You don't have to worry about it as much. They're super fast. It's just churning off prints left and right. Those are really good files to build some of those things. You don't really have to paint it all that much, right? It's one color. So there's not a lot of detail painting except for maybe the helmet. I've never built one, so I figured I'd give it a shot. Half assembled behind me. But yeah, no post-processing yet, so it's going to take me a while to get all that painted and then assembled. I'm not very good at that. Getting it to stick to something, I'm not super experienced with that, so we'll see how that works.
Yeah.
Probably Velcro.
Well, up until this point, we've talked mostly about your Star Wars projects, but before we jump off here today, I was curious to talk more about your geology side of prints, the topography prints that you've done. Can you tell us a little bit about that, maybe some of the softwares that you use to do the different cross sections and how that whole process works? It's super cool if people haven't seen it.
The 3D printing geologic things has got a couple different components to it, but when we're training students, it's that three-dimensional component they struggle with the most. Even people getting lost in the woods, that's the same problem, is you don't know where you are. Your spatial awareness is not as developed as someone who spends a lot of time in the woods. That's just how that works. Trying to train students to think in multiple dimensions is really tricky, especially when they're just in a classroom. If we have a physical model, we can handle them and they can spin that around and look at it. And that's everything from like minerals, mineral shapes, we call it crystal habit, what minerals are shaped like, the chemical lattice structure down at the cellular level or the elemental level. We're talking about all kinds of different scales. The easiest way to do that is to hand somebody a physical model. So with the minerals, we have little wooden blocks, or we can print off little crystals and hand them to them, and they can look at the different shapes. And we use those shapes in geology to identify minerals in a rock. The shape can tell us a lot about the different minerals in a rock. With maps, trying to interpret the topography can tell us what the rocks are, which way they're oriented, are they dipping, where are faults, where are the rocks folded. There's all kinds of stuff we can tell if we can read the topography. And for students, that would be training students to be able to read the topography and then think into the ground. That drove us to do a lot of this, not just the 3D printing, but the virtual reality stuff, because that's the same way with virtual reality. You can't rotate in your hand but you
Yeah.
can spin your head and you can look behind you and you can engage your brain's ability to think about things in multiple dimensions. And started printing all kinds of weird stuff, but topography is the easiest one because we can build a topographic model of the surface and then put all the geology down underneath it. And there's multiple ways to do that. The easiest way we have now is using the Bamboo software to colorize everything.
Yeah.
Before that, we were using Blender, which is more powerful, but it takes way longer to do anything in Blender. Yeah. The Bamboo software is just fantastic. You can really quickly layer some things in and do some things super fast in Bamboo that would take you hours in Blender.
Yeah.
We used a software called ArcGIS. It's not a freeware. It's a pretty expensive piece of mapping software that we use. And then we would take that and move that over into Blender. From Blender, we could take that over into Cura. That was the original way. Now there's a lot more tools. The free software that I use, even if I use the expensive software to make something, I will take it over into something called QGIS, which is a freeware. And they've got plugins that allow you to export it directly to, and it's not colorized. You have to do that later, but it's really well thought out. So even if you were going to build, have you ever been to a national park and they have those big 3D models?
Yeah.
You could make one of those super fast in QGIS because it will let you pick the size of the model you want to print. And then it will let you pick how many subdivisions you want to break it up into.
Okay. Yeah.
And it will break it into printable size models if you've thought about how big you want it, and everything will match. We used to try to do this and it was so hard to make things match at the right scale with the right base thickness. It was really hard before that new plugin. Now it'll make a giant model and then parse it into as many chunks as you want, and then it kicks out an STL for each one of them. Then you could print one of these big models and either colorize them later, colorize them in Bamboo, or post-process them and hand print them.
Yeah.
But that's given us a lot of tools to not just create teaching aids, but for our research components. We can build big models, and then if we're doing research or we have some sort of contract with a business, we can print out the area they want to talk about and point at things. Here is the land we're talking about. Here is where this is. It's down under, and here's how far it is beneath. We could even have a model that pulls apart and show them where a resource is at depth or whatever. It's just really powerful because then you can talk to folks that maybe aren't super familiar with thinking into the ground in multiple dimensions. And it's the picture's worth 1,000 words. 3D models even better because they can hold it and look at it. You can see where something is. Oh, I know where that is. It's right over here by that hill. I understand. With a map, they may not fully get that scale. And so that's what we've started using those for. And they're super fun. Sky's the limit because the U.S. Geological Survey has almost total coverage of the United States in high resolution called LiDAR scans of the surface, where they flew over in an aircraft and collected this kind of laser distance data to the aircraft. And so it's super high resolution. In fact, most of the stuff you download is lower resolution than they actually have. They've just shrunk it because you don't want to download the original file. It's way too big. And you can get high resolution and 3D print your neighborhood. At some level, it's down to the resolution of your printer more so than the topography models that are out there. It's crazy. And that's all really new. That's come around in the last 5 years or less. 10 years ago, you couldn't have done this at all in the way that we can now take just anywhere in the US and then export a 3D model. And it's really fun. We've started using UAVs and drones to make our own models, which are even higher resolution than what you can download offline. And so we've got one drone that has a LiDAR system on board, and we go fly missions. In 15 minutes, we can scan, 100 acres with the LiDAR and then build a super detailed model, way more detailed than you can download. And we could take that, build the model, and colorize it, send it to the printer, print it out. Usually there's engineers involved, so we can send them the model, and they'll use that. That's some of the newer stuff we've been doing, and that opens so many options for what you can do. Last August, I was in Iceland when the volcano was going off, and I had flown my small drone around the volcano and up and down the lava flows. We were getting video to document the eruption. About 2 months ago, I was like, I wonder if I could take and extract pictures from the video and use that to create a 3D model just from the pictures. And that's another technique called photogrammetry, where if you have two pictures, this software we use called Metashape can infer the distance from two pictures. And so if I've got 10-minute long video, I've got thousands of pictures. And so I can take those and create a 3D model using pictures alone. Now we've got a picture, we can colorize it and 3D print a volcano, then have it pull apart or look underneath. You can see the structure of the volcano at depth and show that to students so they can get that reference.
Yeah.
And if you have, again, that model, and you can turn it and go, oh, I see how that works now. And we used to do those. You remember in geometry class, those poorly drawn cubes? This side is this. We have something like that, but there's geology on all the sides. And that's how they used to learn. And that's not super efficient, just drawing on a cube on a flat piece of paper. Now we're starting to build those so that the students can see the sides. For next year, the class I teach that uses those concepts, I'm going to print off a bunch of 3D cubes and cover them in paint so that they can draw on them with white erase markers.
Yeah.
Now they can draw on a 3D block instead of having to draw on a piece of paper. There's just a lot of options. If you could dream it up, you can make it. And that's super fun because the resources are there now. And they weren't like 5 years ago.
Yeah.
You couldn't do this 5 years ago. And now you can just, if you need something, you just generate it. My colleague, he's a paleontologist. And so we're fighting over the printers at work. I'm printing off mountains and he's printing out fossils. He needs a fossil for class to talk about, I don't know, whatever paleontologists talk about.
Yeah.
It's a button and then there's a jaw that he needs to talk about. It's wild what we can generate now and the resources we have now that we can take and use in the 3D printed product, VR. That's super useful as well in the exact same way as we can just take kids to the model of Iceland, put this headset on, then you're standing next to the volcano. That's wild. And that's not something you definitely couldn't have done that 10 years ago. And now if we can build, but if we have to build all these things, that's probably the hardest part is they can be done, but no one's made the content, if that makes sense. And then if they have, it's usually sitting on their hard drive somewhere. We're figuring out how to distribute a lot of this content. That's maybe the trickiest part, but that's the long answer of what we do with 3D printing and geology. It's mostly been focused on building models, mountain belts, stream channels, minerals, different mineral shapes, crystal habits, fossils. Yeah. But we print a lot of them.
Yeah. If for anybody who hasn't seen, I think they're pinned on your TikTok account, but you have some really cool examples of different topographies that you printed and like the methods for doing it. I honestly had no idea that was something that was even possible. So I thought that was really cool. And like I said, I'm sure it's scratching the surface of what's even possible to do.
I pinned them. I guess a lot of people like those so that people can find them. So people were asking if they can print a lake. That gets slightly more complicated. It can be done, but it is a couple more steps. I need to go make one and show how to do it. All the data is free. If you're not in the US, it gets trickier. The US has really good topography coverage. If you're not in the US, the best data still might be the US Geological Survey's data. And this just tells you how old it is. It's from something called the Shuttle Radar Topography Missions. They put a radar on the space shuttle, and the radar bounced off the surface of the Earth, and they used that to build these terrain models.
Oh, wow.
With huge portions of the Earth, that's still some of the best topography data. So that's another resource. It's not near as detailed as the stuff you can get in the US where you can see your house or trees. That's my favorite one. When you can see all the trees and the little forests and stuff. It's wild where you can, again, see a tree. Or we used some of that data a while back to find sinkholes. And the sinkholes are maybe 4 feet across. And we can see the hole in the ground from the LiDAR data. It's wild.
Something interesting you mentioned is, I don't know if calling it like a 3D mindset is the right way to phrase it. For me, getting into 3D printing was the first time like I would try 3D modeling softwares. And I think we're like naturally so trained to think of things on a 2D plane, and you flip the model, like you turn it slightly and you're like, oh my God, this thing looks crazy. So I don't think it's very innate for a lot of people to think that way.
Spatial problem solving really for the geologists, thinking in space. But it's the first thing they learn is in a class called mineralogy. We hand them, they're just wooden blocks. And it's so funny. Once they this is when they're like sophomores in college. And then when they become seniors, hey, you remember those blocks? Like, I don't want to talk about the blocks anymore. Because they're taught to think about like how much symmetry they have and all these kind of components. You probably wouldn't think are geology, but they have to sit there and more or less be able to envision the 3D block in their mind, rotate it, and answer questions about it. And you can see them when they're first doing it. They're like, oh God, this is awful. I think my head's going to explode. And the truth is they almost never actually have to do that. They just need to start thinking in 3 dimensions. So we make them think about the hardest thing possible which is just a little wooden block. We show them the blocks. They just have to think about it in their brain to develop, rewire your brain in three dimensions. But then when we get out in the mountains, they're doing that exact same thing and thinking up here and then down beneath their feet, even having to do geometry problems, doing math in 3 dimensions. And that's the first step, thinking about crystal shapes. And then it just gets worse and worse. But then they get better and better at it. And it's everything. Even we think about the Earth and even on these software, these mapping software, they have to flatten everything. And you have to correct for that in the right way, right? If you're doing something big enough, you don't correct for the curvature of the Earth, you're going to have problems with your map. You might be off in one spot versus somewhere else. Teaching them to think about all those different components is fun to watch. It's three-dimensional thinking is really all we truly train them to do. We teach them a little bit of content. It's the thinking in the 3 dimensions that's really important for when they get out and they go get jobs and do geology out for money. That's why we rely on printing and having something they can physically stare at and think about. But what I'd love to have is every time I go on a field trip, have a model. Here's where we are. You're looking at this. Well, instead of on a map, they just don't correlate as easily. But if they're holding it here, you can quite literally look in the distance and see a mountain and then look down on the model and, oh, I see it. You just can't do that with a map. It's really become useful to have some of these tools to get them dialed in, especially when we're out in the field or looking at maps. It's fun. It's really fun.
It's very interesting to hear about. It's something I don't think I've ever heard anybody, at least from a 3D printing angle, talk about it this way. And it's something that I hope we do more content on in the future, because I think a lot of people
will make some more.
On it.
Yeah, you talked about 3D modeling. So art, sculpting. There's maybe more art in science than I think people appreciate. There's more science in art, whichever way you want to think about it. But there's a lot of overlap that maybe gets lost in the context. But yeah, same thing when you're modeling something. If you're spinning it around, you have to think on the front end, the back, side, bottom. When you put those layers in on the bamboo slicer, and I didn't mean to do that. That's the same kind of concept, spatial thinking. But yeah, it's not something we do very well naturally. And so we have to rewire our brains.
As somebody who's tried to learn 3D modeling over the years, it's definitely not natural, but I think it gets easier over time for sure.
That still bites me every once in a while. The Z-axis got me again.
It has been so interesting learning about all the intersections of 3D printing that you do and all the different projects that you have going on and have done in the past. For people who don't follow you already, where can people follow along with you online for future projects?
I only have the TikTok. I probably should start a YouTube page and have more detail. Again, I've just gotten lazy with it. It's really easy to sit there with my phone and just shoot a little TikTok, whereas I feel like I have to put more time and effort into a YouTube, and I probably would never get those done. If I get motivated, I will maybe make a YouTube at some point, but for now, it's just the TikTok.
That's okay. For now, we'll all enjoy your TikToks, and we'll hold our breath out there for your YouTube in the future. Matt, thank you again. It's been a pleasure talking to you. That has been Meet the Makers.